When simplifying any rational expression, it's in its simplest form when your numerator and your denominator have no common factors except one. So to simplify any rational expression, factor your numerator, factor your denominator, and then divide out any common factors. We treat these a lot like fractions. So if you're looking at, let's just say, 12 over 16, and I ask you to reduce that, you're going to take out common factors that it has. You can take out the first factor of 2 to make it equal 6 over 8. Then you can take out another factor of 2 to make it 3 over 4. So that's the same concept that you're going to do with all of these rationals. So if you look, and we'll just start here at this one, 5 and 2 have nothing in common, but you have a y cubed and a y squared. This is just like the one chapter we did before where we were simplifying monomials. So we said, all right, well, I've got 3 y's up here, I've got 2 y's down here. I can simplify so that I have a 5 and a y left in the numerator, and then a 2 left in my denominator. That is a 5. When you don't have a monomial and you have a binomial, you are going to want to factor it first. However, I just forgot something extremely important with this one right here. You have to state any restriction on the variable. So when you think about a restriction on a variable, we look up here, and it's these excluded values right here. It's any value that's going to make the denominator equal 0 because you cannot divide by 0. So if you're looking at number 7, it doesn't appear that there is any restriction on the variable because you have a 2 in your denominator. But one of the most important things to remember is that when you are simplifying these, you have to go back to your original problem. So even though we don't have a variable in our denominator once we simplified, in the beginning we did. We had a y in the denominator. So in this instance, y cannot equal 0. So for number 8, the first thing we want to do is factor the numerator. So you have a GCF of 8x times the quantity of x plus 1 over 12x squared. Now we can simplify this. So you can take your coefficients and you can take a 4 out of both of those. You have a 2 and a 3 left over. And then you have an x here, x squared, so you have x left over in the denominator. So your numerator is going to be 2 times the quantity of x plus 1 over 3x. In this instance, the value that would make it equal to 0 would actually be 0. So x can't be 0. It can be any other real number but 0. To figure that out, you can always take your denominators and set them equal to 0 and then solve to get what its restriction is. So when you have a little bit more to the problems, like we do on this next page, you'll see that for number 9, we're going to factor numerator because you have a GCF of 2 times the quantity of b plus 8. Whoops, excuse me, b plus 4. So, and then in a denominator, factor of 7 times the quantity of b plus 4 again. Now we have a common binomial factor that we're going to simplify out. So b plus 4 divided by b plus 4 is going to equal 1. So you're going to be left with 2 7s. Here, again, we don't have a variable in our denominator when we simplify it, but we did in the beginning. And you had b plus 4 in the beginning. So we want to see what b plus 4 can't be. So if I subtract 4 from both sides, I'll find out that b cannot be negative 4. That's our restriction. This is our rational in its simplest form. So now if we look at number 12, you're going to see that you have 2 trinomials. One big mistake kids always make year after year is that they say, okay, well, I'm going to reduce the c squareds. I'm going to reduce these, and I'm going to reduce these. You cannot do that because they're held together through the plus and minus. So what you need to do is you actually have to factor them and see what kind of binomial factors, common binomial factors you have. So the first one, the c squared plus c minus 12 is going to factor into c plus 4 times the quantity of c minus 3. Okay, the denominator is going to factor into c plus 4 times the quantity of c minus 5. So you're going to see you have a common binomial factor of c plus 4 that can divide out. Now I can divide these because they're held together through multiplication. So it's going to reduce to c minus 3 over c minus 5. The easiest thing to do is to go back to the binomial when you have them factored completely right here to say, okay, what are my excluded values? What are my restrictions on the variable? Well, the first one is going to be c can't be negative 4. This one's going to be c can't be 5 then. So your restriction on your variable are negative 4 and 5. So when you do these, you're going to keep going through and you're going to try to find common binomial factors that you can reduce. The last one I want to show you is number 14 here. 13 is the same as 14. So the first thing you want to do is always multiply, or FOIL, factor, good Lord. Factor this, so you're going to get z minus 8 times the quantity of z, yeah, we'll just make that look like a real z. Z minus 8 times the quantity of z plus 2 over, what is it doing? Sometimes technology. Over 8 minus z. Now, one of the biggest mistakes that kids make again is they will say, all right, z minus 8 and 8 minus z, two are the same thing. They are not. So in order to make them the same, you are going to actually have to factor out a negative 1 from one of the binomials. I'm just going to factor it out from the numerator, because I don't like to deal with a negative, what looks like a negative in my denominator. So I'm going to take it out of here. And I'm going to say, okay, well, if I factor out a negative 1, it's going to become negative times the quantity of, so z divided by negative 1 gives me negative z. Negative 8 divided by negative 1 gives me a positive 8. So I factored a negative 1 out of this binomial. So let me rewrite. So sloppy. So z plus 2. Over 8 minus z. Now you have that common binomial factor of 8 minus z. So I can reduce those two. So you're going to be left with negative times the quantity of z plus 2 over 1. You're not going to have a denominator. Just realize that. So you don't need that. So now the next thing I have to do is write my restrictions, and my variable cannot equal 8. A lot of students will say it can't be negative 2 either, but that's in your numerator. So you can have 0 in your numerator, and they'll say, well, wait, what about from here? Well, you can also think of that as being in your numerator, because it's like it's over 1. Any whole number can be over 1, so 1 is in your denominator, and z plus 2 is in your numerator. So when you simplify rational expressions, you're looking for any factor in the binomials, trinomials that can be reduced. They can either be just a simple variable factor, they can be a coefficient factor, or they could be a binomial factor. And then you reduce and make sure that you state your restrictions on your variable.